And welcome to this new video. And in this video I want to take a look at this PlayStation 3 motherboard. And as you can see, it is pretty empty and not how a motherboard is supposed to look like. And that is because I've used this in the past as a motherboard because I was not able to fix this at the time due to my soldering skills simply not being at the level that's good enough to fix this type of controller. The original issue with this motherboard, I'm pretty sure, is the analog sticks were both bad, and when I tried to remove it from the motherboard, you can see I damaged a trace right here. So this part of the trace is gone. That is the original fault, and I could not really do any trace repair at the time, so I just decided to use this as a spare. But recently I have been going to some of my spare motherboards, and I have fixed another one of the same motherboard. And I thought, well, why not do one on video? Because this one has multiple things missing or has some multiple things wrong with it. Yeah, let me take you to what is all wrong with this motherboard. Yeah, the first thing I want to mention is that this motherboard is a official PlayStation 3 motherboard. This is known as a Asuka motherboard, as you can see right here. And it is believed that this type of motherboard is official, but it was not made by Sony. Instead, it was completely outsourced. And unfortunately, there are definitely multiple things wrong with the controllers, which these PCBs come with. So the Flex PCB, for example, is faulty a lot of the time, and also the analog sticks are faulty a lot of the time. And there's also something unique about those analog sticks, but I want to go into that later. So let's go over what's all missing from this motherboard and the things we will need to fix in this video. So let me start right here again. So here you can see it's marked in red right now, but this part of the trace is missing. And I don't think this is a ground connection. And since it is directly connected to this one, so this is not a ground, so we need to fix it anyway. So we will need to do a trace repair right here. I took a component off right here. I'm pretty sure it's a transistor responsible for the functionality of the rumble. You can see a similar component right here. So I will need to take that from a donor board. I may need to replace this right here as well. Probably a capacitor missing. Then we go right here, we see we have almost all the LEDs missing. Those go faulty a lot on this type of PCB too for some reason. So we see that 3 LEDs are missing. I'm pretty sure I've used this as a spare. So I'll probably take this one off as well and just get a complete new set of LEDs on from a motherboard. So we need to replace that. Then I turn the motherboard around and yeah, you can see I put some kind of cross across the USB port. That's because you can see the clasp right here is not aligned anymore. So if we don't replace it in the future, it's very likely going to give some trouble. So we might as well replace it when we add it. And of course, lastly, we need to replace the analog sticks. So I told you that there was something unique about this analog stick. Yeah, you can see this replacement stick I have here. This part is the correct size. So if I put that in, well, let's try the other one actually. If I put this in right here, if I try to install this in the motherboard, you can see that the potentiometers are aligned, the main ground legs are aligned. But here where the R3 L3 button is not aligned. That is because this is a different layout than the sticks used by Asuka. So I'm pretty sure I have a spare stick. This one is faulty, but I try to keep them just in case. So maybe I can take the faulty part from one analog stick and then replace it with the other one. So as you can see here, you can see this button is smaller than the replacement one we have. So this one is not going to fit directly into the motherboard, and unfortunately you cannot get this configuration with a large box and a small button. This is the button size of the PlayStation 4 sticks or the Xbox One sticks. So that's a little bit unique. So yeah, the way I go around that is to bend these legs like this for all of them, then install it in there, and then I put a wire through here, right here. So one on this point, and then I take another wire from this point and I put it like that onto the analog stick like that. But yeah, now that we have discussed what we all need to do with this motherboard, yeah, let's just get started. And I think I will get started with the LED points, since it is nice and simple to take them off and install new ones. So yeah, let's start there. Alright, so I will be going into a voiceover for a little bit, because unfortunately the audio I recorded when replacing the LEDs got corrupted due to my laptop dying when I was recording, so the audio file did not survive. But that's okay, so let me give you a quick recap of what happened here. So you just first saw me testing the LEDs which I want to use to replace the missing ones from the motherboard. And the original idea was that I also would replace the LED which was already on the motherboard we are working on, so that we have 4 equal LEDs. Unfortunately, when removing the LEDs from the donor board I was using, I lost one of the LEDs, which then I thought to myself that maybe I would just keep the LED which was already on the board since it was in working condition, and then just replace the other 3 LEDs, which, well, it sounds like a pretty solid plan. Then I just, well, did the replacement thing, I installed them all, and then after that I tested them, and the first and second replacements were both working perfectly fine. Unfortunately, by the last LED, it just wasn't working properly. It was a very intermittent issue where sometimes it would be working and sometimes not. I think maybe the LED itself was working, but the connection with the bottom side of the LED, the side that is connecting to the motherboard, that I think there may have been a bit of a breakage in there, maybe due to the heat on the LED, it may not have survived properly. So after lots of testing, I decided that I would also be replacing that LED. So I took a second spare motherboard and tested the LEDs on there obviously first to make sure it's working. And yeah, then I just took 2 LEDs off of there just to be sure in case maybe one got screwed up. And then I replaced the last LED and then it seemed to be working fine. So it was a bit of a hassle with the LED replacement, a bit more of a struggle than I expected, but essentially it was definitely doable. With the hot air station, I definitely recommend using a hot air station to do any type of LED replacements. So after the LED replacements, I immediately moved on to replacing the transistor and the capacitor that were missing on our motherboard. For that I used a replacement motherboard which was similar to the motherboard we are working on. So I took another Asuka motherboard to make sure there are no issues in using different types of brands of transistors. I'm not sure if that could cause any problems, so I just wanted to prevent that by using a similar motherboard. The replacing of the components itself was pretty uneventful. And yeah, I just took off the donor motherboard and then put them on the motherboard we are working on. So it's been a few weeks since I last recorded for this video, and I think what we are going to do next is the USB port, which should be pretty straightforward, especially since literally yesterday I got a new hot air station. I've got the Eton 862D, so basically the most known one so basically the most known one in the industry, I think. I've practiced with the hot air station on some PlayStation 3 motherboards, and I managed to remove the USB ports on one of the boards without adding anything. So I think it is interesting to test it out a little bit more. So for temperature I'm going 390, and for airflow I'm going 50%. And yeah, let's go. Let's see how well the hot air station does. Maybe I will add a little bit of flux to help with the airflow of the solder. So there we go. It's maybe good to know that I upgraded from a €30 hot air station, very simple. It did the job perfectly fine, but it had a little bit of a problem even the last few times I used the hot air station, where the fan was not really spinning properly and it would just stop and go again. So I did not really trust the device anymore. So I thought it made sense to finally make the upgrade to a very proper station. And yeah, so far I'm very happy with it. It slowly wants to start getting out, so I think we need to give it maybe a minute, maybe less. As long as we keep the air spinning, we should be perfectly fine. Yeah, you see it wants to go. Yeah, and it's out. Yeah, this thing is amazing. Can't say otherwise. Not a pay-per-view, by the way. But yeah, if you're searching for an upgrade for my cheap hot air station, I can definitely recommend this station. So now let's clean this up with some IPA and a Q-tip. This is some permanent mark I put on there, so it might not go away completely, but it's okay. As long as the flux is gone, I'm happy. Okay, so I think this is ready for a replacement USB port. And since I have a few different types, I will show you which one I will use. Of course we need one with the 2-hole pins, since this one is also 2-hole. Mostly I tend to go with this replacement, which is 2-hole, and of course you may notice that there are no back pins. But unfortunately the 4-pin 2-hole version of this USB port does not fit for some reason, which maybe I can show that to you. Here's the 4-pin USB port. Here's the one we just took out. And I know there is some solder on the USB port, but yeah, the legs are a little bit differently positioned, which makes it so that this port doesn't really fit that nicely. So most of the time the hind legs I will just bend them up so they can fit, but for now we can do perfectly fine with the 2-legged USB port. Okay, yeah, so that is in, so we can install it right now. I will use the soldering iron for installing the USB port. I use my soldering iron at 350 Celsius in this case. And I will use leaded solder to reinstall the USB port. Okay, I will use a little bit of flux since the solder does not really want to transfer. Okay, I said a little bit, well, I guess not a little bit. But that should be more than enough. So that's perfectly fine. That's also okay for now. I will also tin the hind ground holes, because I will desolder the USB port there. I will solder the USB port there. Okay, so I think that all has solder on it, so now let's make this pretty. That is good. And that is fine. Now let's turn around the motherboard. And I will try and put some solder right here. No, I don't think you can see it. I will put some solder right here to still make sure the port is going to be solid. It may be difficult for you to see, unfortunately, but I will show the end result. And that's also why I put some solder on the hind ground legs, or ground holes, so that it will connect from there. So that should be good. So still need to do some cleanup, but here you can see the end result. If it focuses, you can see that the solder we put on the back has gone through, and with the extra solder added from here, it will connect to the outside of the USB port, which is also ground, so it should be a perfectly solid connection. And yeah, I think it's nice and flush with the motherboard, so I think our job is done with that. And then for the next section, which will be the most interesting one, we will need to do a trace repair right here. and we will install the analog sticks, but we will do that under the microscope, so I will see you there. So here we are under the microscope, and as you can see we are looking at a capacitor, and this capacitor is from a donor board. The reason for that is that we are missing this one on the motherboard we are working on, and I did not notice that until now. So what we're going to do first is we will remove the cap from here, and then we will reinstall it on our board that we are working on. And after that we will move on to working on installing the analog sticks. And of course we are going to use the hot air station again. I think 350 Celsius will be enough at a 50% airflow speed. So there we go. So now the cap is removed from this donor board, we can install it on our motherboard. I just need to check if we need to add some more solder or if there is enough, and clearly we need to add some. So I will do that first. I guess we should get rid of the wet marking there first, before I go over that with the soldering iron. It's not fun stuff to read in when it's being heated up. And then the soldering iron also at 350 Celsius. So this should be plenty. Just going to add some new flux purely to keep the capacitor in place. I do not want to risk it flying off when I put the heat on. So let's try to put this into place as accurately as possible. So I put some IPA on my tweezers, so hopefully it doesn't stick as much. Just want it to be aligned with the solder pads. I will settle for that. So now we go back to the hot air station, same temperature as before, and same airflow speed as well. And if everything goes well, it should go into place by itself. Maybe it needs a little bit of a nudge. And I need to actually push the button so it's so the station turns on. And there we go, it's already into place. So that's looking solid, I think. Yeah. Oh. And the motherboard did not want to show itself. So let me try that again. Yeah, that is very nicely into place. That is looking good. So what we move on to is all of this, which is all trace damage caused by me when removing the original stick. And this was, well, maybe this was years ago. It's a very old donor board. When removing the analog stick, and I think I just desoldered it at the time with a soldering iron and some wick. I pushed under it with a bit of a dental pick, something like this. Then I tried to push the stick out like that, and yeah, that has caused some trace damage. It has not cut the trace. I did test all of the actions and all of it has continuity under the microscope. So the only thing I need to do is cover it up with some solder mask and make sure that it's not going to short out or something in the future. So do that next. And here's some on the other side with the other analog stick. We also have some spots, as you can see. So here's the solder mask. I use the orange stuff, and just we need to make sure that we only cover the exposed faces, and okay, we do not really cover the rest where the analog stick pins are supposed to go through, because of course you want to keep a good connection right there. We do not need too thick of a layer, since you also want the analog stick to be flush, so I think I already have plenty on here actually. So I think we are there finally. Oh, one spot. That's what happens when you are inexperienced with removing analog stick. You get this amount of damage, and I got lucky that now for one, of course except for one trace, but the rest survived pretty well. And I see something right here as well. So I think everything is covered that needs to be covered. Only right here I will remove some of the solder mask we put on, because it's very fluid, so it tends to spread very quickly. So then it also goes places where it doesn't need to go. So now I will just let it cure, and I'll be back with you when everything is fully cured. Alright, we are back, and as you can see, the solder mask has cured. And this ended up taking around 5 minutes for everything to nicely cure. Had to have a bit of patience, but what I did in the meantime, if I remove this, is from the analog stick, which is very zoomed in right now. Apologies for that. We'll zoom it out a bit. Okay, that's better. So here we have the still zoomed in analog stick. And the way we need to install it, it's needed that for the L3 R3 button, the clicky button, these legs need to be flattened, because otherwise the analog stick is not going to fit on the motherboard. So I will show this one on camera, and it's a very simple procedure. I just use my, I think these are needle nose pliers, and we just need to bend it like that. And only the two front legs, I think these one can stay. Well, actually they can't, now that I think about it. So we need to do these for all 4 of them. I don't know why I did not do the other 2. Because the whole button is not going to fit where it is supposed to go. So to get around that, we need to flatten these legs. So it's going to go into the controller like this. And I will do the same for this one quickly. So the analog sticks are prepped, but for now we are going to put them to the side, because we have work to do on the motherboard itself, and I will focus you. So here's the trace damage, which starts right here and it goes right here. And yeah, what we need to do right there is we need to put a wire from here. I guess we could connect it to the cap. Maybe I will put it right here. Not too sure about that. That kind of depends on what is easier. What I will do is get rid of this, because we cannot use this anymore. So one thing we need to do is that we need to put a wire across this point. But we also need the leg of the analog stick to connect to this part. So I think maybe I will put 2 traces across here, and one goes to this cap, and if I can show that properly, the other one is going to go through like this, so it can connect to the leg under there. So the first thing we will do is do a bit of prepping, and if this is loose I will also remove this, because this will go off due to the heat I'm going to be putting on here anyway, so I might as well remove this if this is loose enough. So then it's best to just disconnect it. May need a little help here of a blade, so I do not pull the rest of the of course I do not want to damage more of the solder mask either. And if it doesn't want to go, then I can just leave it as is. I unfortunately do not have a very sharp knife where you can just do this and then it is loose, so I will let it stay for now, but I'm not going to be connecting the wire to here. I will move a little bit back, and with this grinding pen I will expose some of the trays right here. So just a little bit more, then we have plenty of space to install a new wire. So that's good enough for that side. And then right here I'll probably expose a little bit of trace right here. There's only one wire that needs to go away obviously, so we do not need to expose the whole thing. It's a bit overkill I think. So next step is to put some tin on the exposed trace parts. which of course we can use the soldering iron again. So yeah, we can start by putting a wire on here, at least one of the two. And to do that we need to scrape away some of the enabled, which you can burn away, so that's why I'm holding the soldering iron over it. You could also maybe use something like a Stanley knife and just scrape it away, but yeah, might as well try to burn it. And now it should install relatively easily. I can hold this still. It needs to be flat to the motherboard or else it will move too much. So that's perfect. And that should be plenty. So now I will try to lay it flat as possible, to try and solder it on relatively quickly so the other wire does not get lost, which is a bit of a risk. I may actually use tweezers to reduce that chance. This looks very ugly right now, but at least it is connected. I will just patch it up a little bit with some fresh flux and some fresh solder. So there we go, that should be good enough. And then from this part we're going to do the very same thing with it with the other two traces, and that's just scrape away the enameled part and then we should be able to connect it. It technically is connected right now, but it's not a very strong connection, so I will come in with more solder, more flux. That is a solid connection, and I don't think that's going to go anywhere. So I will break off this part, and I should be able to do so by shaking it. And then what we need to do is we need to clean this up, and then we need to put some solder mask on. So I will do that again and then I will be back with you. Okay, so I am back, and as you can see we did not do anything with the solder mask yet. I just realized that the way I connected the traces right here, I'm not sure if that's going to cause any issues with the lag or something, because it's a bit of a weird connection. I mean, maybe it could work, but I think it's better if I leave the original trace, which goes down right there. Then I leave this part of the other trace, but instead of having it connected right here, I'm also going to push it through right here. And then I can connect both sides onto the pin, so it's just one continuous trace instead of having one part connected while omitting this part, and the other part goes right here, and it doesn't really add up. I thought it was a good idea, but now that I think about it, it's probably not a good idea. So this is the trace I want to remove. Okay, so it is connected right now. I think that is a good connection. And this part can go. And the only thing we need to do is pull that other trace through as well. The wire is long enough that it should be able to make the connection. So this should be fine. But yeah, I think this is a better connection. I don't think this will cause any errors with the controller, or with voltages going places where they're not really supposed to go, or it being unequal distributed or something. So I feel a bit better about that. So now I will actually go ahead and put solder mask on, and then I will be back with you. Alright, we are back, and as you can see I put some solder mask over the wire so it doesn't go anywhere. And this is the other side. If you flip it, there are the two wires which we will connect later. And the next step is that we need to clean out some of the solder. We need to get the hot air on this and the soldering iron, I think. Hot air to warm it up a little bit, and then I can just remove it with the soldering iron. I hope I can capture this a little properly under the microscope. I think this is a little bit better, so you can see right here where we need to work. I will try the hot air station first. in combination with the desoldering pump, if I know where I put it, oh right here. And I will put the hot air station. I think I will try 380 again at 50% airflow. First I will heat up the whole board in general, so the solder will melt a little bit quicker. And again, I did not really add anything of leaded solder. I don't think it's needed, because this hot air station is simply a little bit more powerful, so it should be able to melt the solder perfectly fine. So as you can see with the hot air station, everything is now looking nice and clean. So I will let it cool down a little bit. I will clean it with some IPA real quick. Okay, so the next thing we are going to do is we are going to pull some more wires, and this time it will be for the L3 and R3 buttons. And we will only pull two wires, because we only need 2 of these connections to make the button work. Which, if we turn this around, means we will pull one wire through here and one wire through here. Then we will take the wire. You can pull it through. Something like that, for example. And then we will do the same for this one. I will clean up these solder joints later. I always like to put some solder in these ones anyway. And then I will do the same from the other side. So this is the other side done of the analog stick. So I will flip around the board so you can see it from this side. And here's the other side. And yeah, you can see that on this side I did not fill these holes yet, but we can do that later when installing the whole analog stick. Kind of forgot about it, to be honest. And even here the solder hasn't even go through fully. But now we finally go to the interesting part, which is of course installing the analog stick. And now we can finally go ahead and install these into the controller. Of course you need to make sure that these traces or this wire is completely flush, since we need to be able to solder this. So that should be fine. So then we can take one analog stick and install that. So this one went through perfectly fine. I will try and show you that. So yeah, you can see it's completely flush with the board, which is what we want. And of course the most important part is that here we have the trace for the analog stick, at least for the L3 R3, which can fit there perfectly fine, so we can solder that okay. And it's the same for this side. You can solder that there perfectly fine. Maybe that's a bit better. So now we will also line these two up. I guess these are already lined up pretty okay. So now we can install this one. And yeah, you can see that this is also lined up pretty fine. I can work with this. This one is aligned perfectly, I guess. And if you go to right here, you can see the wires right here, which we need to work with. They need to be connected to this analog stick. So when installing these, you want to make sure that the analog stick is completely flush with the motherboard, which this is not 100% flush. That is why I will hold the stick in place when I'm soldering the ground legs first. So then so then the analog stick will hold itself into place. So here it's not completely flush. It's also because of the wire, I think. If you look at this analog stick, I guess it's a little bit better in place. But yeah, now I will put a little bit of solder on the ground legs. And then we can start soldering them. We have done the major work on this motherboard, and then we can test if all of our effort was worth it in the end. Because we are reviving a donor board, obviously, so as far as I know, there was nothing major wrong with it. But I never really got around to working on this again, because I had so many other projects that I kind of forgot about it. I mean, even if we do not get it to work. At least it was fun practice to work on this board. So what we do right now is hold this analog stick into place, and then we will solder this into place a little bit. Not perfect, but as long as it's holding onto something, then it's perfectly fine. Okay, as you can see, I've already soldered most of these points. The only things I want to show you is me installing the wires onto this pin, and then I will also show you the soldering of the L3 R3 traces. So I'm not really sure what the best way is to go about this, but we need to try and scrape the enameled part of this wire. So that one is exposed. Now we just need this wire. I mean, I guess that will work. Need to try and wrap this around the pin. Then we can try and solder it. I guess a little bit of flux should be helpful. I think that is soldered on decently. I'll see if I can get this to connect a bit. I mean, it's good enough. It should be connecting the two traces together, or the whole trace together, I guess. And to test that, I will actually flip around the board. Oh, I'm not sure how we can test it if it actually works. I did not think that through very much, admittedly. But you can see the left pin right there. That is where we worked on. I don't think it's going to be interview 100%, but this pin right here goes to this testing point, test T505. So I have one probe on there, and then the other one goes right here. I don't know if you can hear that, but the multimeter is beeping, which means that there is a connection right there. So I think we can conclude based on that the trace is repaired and is working. So that means that I can take off this trace wire. I have no idea why I keep confusing the two, but we should be able to take off this wire. Otherwise I can just cut it if it doesn't want to go. So we can at least do a bit of cleanup around here. And I think with the Q-tip I took off that bit of wire, so that is perfectly fine. So here we are at the top of the analog stick, and here we can see the wire, one of the wires that we need to install. And then of course for the other side as well. That's right there and right there. So I think we will start with this one, and it's a bit of a tight fit, but it's definitely doable. We need to add a little bit of flux, and then we need to kind of fit the soldering iron in there. And this is definitely where a bent tip like this is definitely handy, so then we should be able to install it like that. But yeah, it may take a few tries, and yeah, we will definitely melt part of that white plastic right there. But you cannot really prevent that, I think. Well, maybe you can use a different solder tip, but yeah, since the latter part of the soldering iron has the solder on it. So what I can do is put a bit more solder up front and see if that wants to install, and that seems to work. We'll add a little bit more flux just to make a more solid connection. Then if we take a pair of tweezers and we move the pin around, it should stay with the pin right there. So you can see the wire is fully connected, so that is good. That should hold fine. So then we can move on to this pin, and yeah, it's basically the same procedure. So I think we will just speed this up and until we are on the other side of the analog sticks. Alright, so here we are at the other side of the analog stick. And we will do the same thing here actually. It's not very surprising, isn't it? It's a similar procedure. And I guess optional, if you really want to make sure the button is working, or if you're not really confident that your connections are not very strong, then of course you can solder all of the pins this way, but yeah, I always have done too. And that has been working fine for me, so I just keep on doing that. I guess the only downside is that you keep burning the white plastic, which, well, it doesn't smell very nice. And of course the stick doesn't look very nice. So it's connected, but I want to have a stronger connection. So rinse and repeat with the flux. And burning the plastic, of course. Can't miss. Yeah, this should be perfectly fine. It's definitely solidly connected. So I will do this last wire. So as you can see, our last wire is also installed. Before we do anything else, it's wise to test the button right now to make sure that our work that we did actually works. So I will get the multimeter. I will get it in continuity mode. I will turn off the fume extractor, so hopefully you can hear it. And then we will put one probe here and one probe there. I will try and hold them into place with one hand. And then the other hand can actually press the button. That side is not working. Maybe there's more hope for this side. So let's try it from up here and see if we try from here if it actually works. And it's still doing nothing. The only thing I can come up with is that the enabled part of the wire did not actually burn when installing it into the solder. So what I will do is grab the soldering iron and I will heat it up again. And yeah, I will be back with you when I think it's fixed. Alright, we are back again, and the only thing I did is I just grabbed my soldering iron with some solder and I just heated up very slowly, or just left it on for, well, let's say 10 seconds to make sure that the enabled part had a chance to burn off. And I did that for all the 4 points, so the 2 points here and the 2 points on the other analog stick. And this is the result right now. If I put one probe there and one probe there. I have no idea if you can hear it, but it's beeping. So I will try it once more, just in case you didn't hear it. So that's now connected, and same for this side. I need to put the probe on. There we go. So you can see it's now working as it should, which means that I think we are done with the major repairing on this motherboard. So I think I will just do a quick recap of what we did. I think we replaced all of the 4 LEDs, which do vary a little bit. We replaced this one, this one and this one. This one is the only original one which was still working. And this one we grabbed from a donor board, and at least from a similar donor board. So ambulance in my street. So we grabbed this one from a donor, also a Asuka motherboard, and these ones are from different revisions. But yeah, these should all work fine. We all installed them in the correct order, so that should be okay. Then I will just move on right here. Here's the USB port. I still need to do the cleaning up on this one. You can see it's installed fine. You can see that the fault lengths are going to the motherboard on the back. I just added some solder to strengthen the connection to make sure that nothing can happen to it. And we had to install some components which I previously stole from the motherboard, so I'm pretty sure this transistor had to be reinstalled, this capacitor right here, and this cap right here as well. Maybe one more component, not sure. But this is all nicely populated, so it should be good to go. And yeah, the last major thing we just did, are the analog sticks, which are very big under the microscope. So here's the analog stick. And under there, of course, on this one we had to do some trace repair. You can see right here, you can see some of the trace repair being done. Yeah, we had to fully replace the analog sticks. We had to cover up some of the damage we did by prying the previous analog sticks off with some solder masks, so that it's not going to short out in the future. And look here, and I'm not sure if this is a missing component or not. Let me check that real quick and verify that. It's not going to influence the testing regardless. At least I'm assuming so. Oh, yeah, it seems that there is a capacitor that maybe is supposed to go there. This is a different revision board, I think. This is a 1.6, the one we're working on, and this donor board is a 1.5. So I'm not 100% sure if this is actually a missing component or if it just unpopulated in this revision. So I will keep an eye out for that, and I will add the capacitor after I verify that the board is working. But yeah, I will mark it on the board at least, so I don't forget about it. So that maybe needs some attention, but it's not going to influence anything major. It shouldn't, at least. But good thing I saw that. And yeah, I think that's everything we've done. So of course there's only one thing we need to do after I've cleaned up the board, is that we are going to test it, so you will see that in the next section. So here we are about to test the controller, and you can see that I did not fully reassemble the controller, so the wumbles are still missing, but all the essential parts are reinstalled, so we can test the buttons and the analog sticks. And when plugging in the controller, you can see that all the LEDs are lighting up, so that is one positive thing already. But unfortunately, when actually testing all the buttons on Gamepad Tester, you can see that the buttons are not really responding. Either there are buttons responding which I'm not pressing, or buttons that I am pressing are not really registering at all. Yeah, the reason for that I did not really know at the time. The other positive thing about testing on the Gamepad Tester is that the analog sticks are fully working, which that means that all of the trace repair we did around that all works fully. So besides the sticks all going in the correct directions, also the L3 and R3 buttons are fully responsive and work perfectly. But yeah, after this I had to figure out what happened with the controller and why half the buttons are not responding properly. So after figuring out that most of the buttons aren't working, I had to open up the controller again, obviously. And the first thing I tried is the most simple thing, is just to clean the pads on the motherboard. Just maybe when cleaning up all of the flux and stuff that we had left on the board, maybe some of it had gotten on the pads, and yeah, maybe that could cause troubles. And while I was there, I realized that the foam piece, which sits under the flex PCB, I did not actually reinforce it with tape, which can also cause problems with buttons not responding, so I thought maybe I'd reinforce that also where we are at it, to make sure that that's not going to cause any problems in the future, so better safe than sorry. So I also fixed that with, well, some double-sided tape, very small, 2 pieces, and then I reinstalled that back into its position. Then of course we had to reinstall the motherboard, make sure everything's clean, and then we could finally test it. And the first thing I found is, of course, yeah, the buttons are spacing. That is because of the fact that the controller is not fully assembled. So I think also here it does not really press together properly, but you can see that L1 is working. But L2 is not responding still, which we need to figure out later. Then R1 and R2 are working. And you will see that we go to all of the buttons, and yeah, basically all of them are responding properly as intended. Which means that it may indeed have been some dirt under solve the pins on the motherboard and or a foam problem. Not sure which one was the biggest problem, but yeah, basically the major problems are solved, but now we need to take a look at the R2 button and see what is wrong there. To figure out what is wrong with the R2 button, I had to take a closer look at where the pins meet the flex PCB, and I noticed that for the trace that goes to the R2 button, there was a bit of a mark on it. So it seemed like the carbon had worn off a bit. So to solve that, I grabbed a pencil and I basically marked that pin on the motherboard to make sure that it had enough carbon on it that it made a solid connection, so that hopefully then the R2 button would register. And now we can finally test the controller again, and as you can see, the R2 button is responding right now, which means that all the buttons are fully registering, and that means that the motherboard is fully functional and is seemingly fixed. What is good to know is that I did actually reassemble it a bit more off camera. So I added the motor, for example, and I put it in a shell. And I played some video games with it and it responded perfectly fine. So no disconnecting of the Bluetooth module. The rumbles are both responding perfectly fine. So the transistor we replaced was good, which means that our little project is done. So I hope you enjoyed the video. If you did, you can like the video and maybe even leave a subscription if you want to see more of this content. I actually have a PlayStation 4 motherboard that is in a similar state as this PlayStation 3 motherboard. It needs a lot of rebuilding of different stuff. If you like that video idea, leave it down in the comments below. And that forms the end of the video. So thanks for watching. I hope it was of any interest or value, and I will see you in the next video. Have a good day.